All right, recording's rolling. It's Friday, February 6th. All right, so yeah, sorry I haven't been able to be here the last couple of days, but you guys have had a couple of days to work on Alex. A lot of you guys got your assignments in, so awesome job there. All your papers that you turned in so far, I did get back to your return folders, so you guys have those. Today we're going to do Module 8 review with Kahoot. The quiz is going to be on Monday, and I moved the last Alex assignment due date also to Monday, so you guys have a couple more days there on that. All right, let's switch over to Kahoot. Yeah. Log base 10 of 1,000.
Well, I mean, great. Oh, wait, I missed
Very
it.
good. All right. So the fastest way is you can punch that in, get to log 1,000, and I'll tell you three. But the guys like, remember what logarithms are. It's telling you an order of magnitude. It's like counting powers, counting like powers of 10 in this case. So, right, so it's like it's like 10 raised to what power? Well, 10 raised to the 3 would be 1,000. Actually, it's probably a good idea to just review all these logarithms anyway, right? I keep this page every day, right? So if you have an exponent like 10 to the 3 is 1,000, you could say, well, log base 10 of 1,000 is equal to 3, right? So you can rearrange one to the other. So an exponent is a logarithm. Right, and while I got this page up, let's go to these other rules. I bet all these are going to be handy throughout the Kahoot. Right, so we got this product property. So a log of two numbers multiplied, you can add the logarithms. Yeah, remember, people actually use this for hundreds of years to multiply large numbers together quickly. Right? Remember, they had that look of logarithms to be clear. You can also divide by subtracting logarithms. Ooh, how about this exponent property? Log of a to the power b, you can pull the exponent down, make it b times log a. If you have some base that's not base 10 and not base e, then you can change the base by doing log A over log B, or if you like natural log A over natural log B, you do that too. Okay. Um, yeah, okay, and then okay, so that's most of the log rules that you guys need right there. All right. All right. What's on the board? Ooh, log base 9. Hmm.
Oh, yeah.
Yeah. All right, here, and I'll show you guys a couple of ways you could solve that. And so here's log base 9 of 81. Right? Right, so one way is you could say, well, if this is equal to, say, x, I could rearrange this as an exponent. So I could say 9 to the power of x is 81. I could say, oh, well, I know 9 squared is 81. So x has to be 2. Right? So that could be the answer. Okay. Another way you can get it is I could say, this is the same thing as natural log of 81 over natural log of 9. I bet that will also give me 2. Okay, let's see if it is. What is natural log of 81 divided by natural log of 9? As long as you have the parentheses in the correct place, this should say 2.
Yeah, I got to.
Yeah, the same thing. Equals 2. Same thing. Right. Can I have done that with the first one?
Nate, what are we doing?
You guys know the first one was log base 10 of 1,000. So here, same process. I could rearrange that, say, 10 to the power of what is 1,000. So x is 3. Okay. Or I could have said natural log of 1,000 over natural log at 10. Okay. I bet this will also give me 3. Natural log 1,000 over natural log 3. Or, oops, sorry. Oops, natural log 10 or not. There we go. Yeah, 3. Ding, ding, ding. All right. Ooh, log base 10 of x is equal to 6. All right. Yeah, 1 million. All right, so I think the fastest way to solve that would be to turn this into an exponent. You can say 10 to the power of 6 is equal to x. And then if you type that in your calculator, that's a million. So x is a million. Okay. Okay. Now, maybe a more convoluted way is you could, well, there might be other ways to go about that. That's probably the fastest way. Okay. Okay.
What makes it?
So, yeah, log base 2 of x is equal to 5. You can rearrange that, say, this 2 to the power of this 5 is equal to this x, like that. So that's 2 times 2 times 2 times 2 times 2, 32.
I think that, but I'm treating like right before I ended it started. Oh,
Here's the point now. All right, ooh, can you expand that?
right now, yellow, yeah.
All right. So here's what I gave you. Now I know I can do the say log of root x and then plus log y to the 3, right? And then okay, and then subtract because it's dividing down here. So minus log 9 and then minus log z to the 5, right? But I could do some other stuff with this too. Right? Like guys, this x right here, square root of x, isn't it actually x to the 1/2? That's the same thing, right? Right? Right. So I'm looking at these powers, like this power 3, this power 5, this power 1/2. I can bring those all in front, right? Which are probably right that way on the quiz. Right? I guess you could even take this 9 and make it 3 squared. You know, I mean, probably do something with that too. Right? So there's different ways to write these. You just have to pick the right multiple choice answer. Right? So 1/2 log x plus 3 log y um, minus log 9 minus 5 log z. Okay. That's probably what I put on the compute. Yeah, there's a couple of different ways to write that. Yeah, yeah, that's it. Yeah. All right, you guys good? All right.
Oh, it's bad. Yeah.
So, so this is like the opposite process of the previous one. You take this one half and put it into this power. Okay, we got natural log. Okay, so I got a square root of x going on. Okay. But you know what? I have three logarithms. They're all the same base. They're all base e. They're all added subtracted. So I can combine it to one logarithm. Okay. We got a 5y in the mix. And then since it's subtracting off natural log of z inside the logarithm, that'd be just divided by b. Okay. That's probably. I type the answer. Let's see if that's it. Yeah, yeah, that's exactly it. That's exactly it right there. Any questions on that one? That's good.
Oh.
Um, Here, guys, help you guys out here. So out of the multiple choice answers, they're all log base two. Right? So log base two starts off as like some hook shape. Now, looks like this has been shifted to the left. Yeah, which of these looks like it's shifted to the left? Yeah, the red and the blue are shifted to the left, right? Now there's this other detail. Ooh, guys, I see a point. This looks like 0, 3. 0, 3. Do you guys see 0, 3? So if you plug in 0, you should get 3. Right. Well, let's try this out. If you plug in 0 for x, what's 0 plus 4?
5.
4. What's log base 2 of 4? Another way to say it is 2 to the power of what is equal to 4?
2 to the power of 2.
2 to the 2. 2 to the 2 is 4. So log base 2 of 4, that's all equal to 2. And if you add 1, does that get you to 3?
Red.
Which looks like that point right there. Yeah, that's gotta be it. That's gotta be it. Right. So you guys know on every quiz I have you guys come up with a graph. And in a lot of quizzes I've been giving you guys a table so you can come up with some table values so you can plot the points and get it draw the graph. Right. So I might have you guys do something like that, like a log base 2 graph. Right. Remember, guys, even though the calculator doesn't know base 2, it does know base 10 or base e, and you can do a change of base. Right. So you can come up with a table of values. So you can do that. You can come up with that table of values. Right. And of course, I've been suggesting you guys some really convenient x coordinates that will work nicely on the graph too. Right? So you come up with some points, plot a logarithm graph. Right? All right. 3 log base 2, 10. Can you do change of base?
Oh.
All right. Okay. So this is what I gave you. Right. Now there might be a couple of ways you could get a valid answer. You just have to get one that matches multiple choice. So one thing I did is I took this 3 and moved it to the exponent. Right. Guys, what is 10 to the power of 3?
Or 1,000.
Yeah, 1,000. Yeah. Right. All right. Now I prompted you guys to use a change of base with natural logarithms. So this is the same thing as natural log of 1,000. over natural log of 2. Okay. Very good. All right, that's the answer. Half-life of thorium-230 is 75,000 years. What's the value of K in a exponential decay?
Oh, Mr. Griffin,
Yeah.
what would T be?
Oh, yeah. You guys see this 75,000 years right here? If you plug that in for the time, since that represents one half-life worth of time, then what do you know about A compared to A naught? It'd be half. Yeah, like whatever you start with, you'll end up with half of that. As long as 75,500 years have passed. Show you guys how to get that. So this is exponential decay. Well, just in general, right? Like here it is for carbon 14. I mean, it starts off the same expression, just decay is different for carbon 14. Right? But if you know the half-life of any substance, you can solve for this K right here, and then you can have an equation with the base of E, and like three-dimensionally date something. Right, so I'm gonna say however much you start with A naught, whatever this A naught is, like 1 gram or 100 grams or whatever, it's gonna become half of that original value as long as one half-life has passed. Does that make sense? Right? We're going from some original value to half of that value, from 100% to 50. You could go from 100 to 50. 50 is half of 100, right? 100% to 50%. Okay. As long as, and I'll plug in for T, 75,500 years have passed. Yeah. Yeah. Like that. Right. And then, so at least an algebra, the solve, yeah, solve is okay. Right, now, Xenon ends up going away. Right, so I have a half here. Right. So if e to the power of something is equal to a half, guys, what's the next step? We see a base of e, when you're solving for the exponent, you got to apply a what? Natural logarithm.
Yes.
So take the natural log of both sides. Natural log of the left side is equal to natural log of the right side. Right? And all this on the right side simplifies to this. And then all you have to do is divide both sides by -75500. Right? Okay. Oh, yeah, your textbook was saying that particular isotope was used to like date corals or something, or maybe it was a different one. One of those. You guys got that in your notes? All right. Oh, okay. Here's one for coral. Right, so there's the formula. A coral contains 90% of its original thorium-230. Oh, and there's K values that we just found together. What's the age of coral?
Wait, Mr. Griffin.
Yeah.
So it would be 9 tenths, right?
90% is 0.9. Yeah, 90% is 0.9. Yeah. Here's our values. Okay, so here's the setup. Okay. So maybe the coral originally had some amount of that isotope. And then now we're down to 90% of that. So as a decimal, that's 0.9 of the original amount. Okay. And that's going to correspond to some time. And the K value, which we found from the last question, is this value right here. So 0.1234599181. And then T. Okay. Now we're solving for T. Okay. Now still the exponent, so it's going to be a similar algebra process. Okay. Okay. Once again, here's the answer to the last question. Okay. We got the K for that isotope. Okay. Now we're applying it to this coral. Is there any question about the setup? Okay. You guys got this? Okay. Guys, what's the next step? What do you have to do to both sides?
Natural log.
Natural log. Yeah, natural log of the left side, natural log of the right side. Okay. So the left side is now natural log of 0.9. The right side, well, this is just going to simplify to this right here. Okay. And last step is divide both sides by this. Okay. So the exact answer is, of course, this right here. But I see type that what I just circled in my calculator, and I should get a number of years. Like how old in years is this? So I'm looking at now. Could you realistically go down to the nearest year with this method? Probably not. So in the multiple choice, I would probably round out a little bit. Everybody read that in the notes? Yes. Yeah.
I did it, it gives me 26,000.
Okay, it might be how you typed it. Right, so here, let's just go to type natural log. It got Ellen. Okay.
Oh, wait, my thing, wait.
Huh?
Recess.
Okay.
Yeah, how about I click second function natural log, which gives me this. Yeah, I did click second function of natural log and give me that LA.
Uh, oh, yeah, you don't go to second. You just hit natural log.
Oh.
Yeah.
Oh, yeah, that's
Yeah,
not bad.
yeah, hit second to get either color.
Oh,
Yeah.
thank you.
Alright. Alright, so you guys good there? Yeah. Alright. So, we guys see the same question on Monday. You're able to get that one. Now solve for x.
Because game. What I did it, it's great.
Alright. Begin. Alright, so what you're solving for is the exponent. So take a logarithm, and since base is b, I'll just cut straight to a natural logarithm. Probably the best choice. So natural log of both sides. Right, so left side is going to be x minus 5, and then natural log 70. So x is 5 plus natural log 70. Right, that's the exact answer. And then 1.25. There's a good approximation right there. Let's solve for x. Okay, so same process as before. You take natural log of both sides. So this over here is just x plus 2. This side is natural log of 100. And let's see what that is. Natural log of 100 is minus 2. So approximately 2.605. I'm gonna do one extra thing with that. Okay. You guys know that for all of these, you can always take your answer and plug it back into the original statement, right? It's like, here, let's try this. 2.605. That is rounded a little bit. So let's see if I do e to the power of. So I got e to the power of. Then I type 2.605 plus 2. Okay. This should be very, very, very close to 100. It should be 99 point something. Let's see. Yeah, it sure is. Yeah. All Brooks. So, okay, so maybe a couple ways to take this. One way is I might change this logarithm back to an exponent form. You do that, right? Or if you like, remember this very last rule, e to the power of ln x, make things x. Right? However you think of it, if I do e to the power of both sides, I could say that, or take this base to the power. It one way or another. I got x minus 2 equals e to the 5. Yeah, there's a couple of ways to think how to get there, but that's the starting point. And just add 2 to both sides. Plus 2 plus 2. Right, so then x is equal to e to the 5, and plus 2. Right, so e to the power of 5, close parenthesis, and plus 2. I'm looking at 150.4. And for the winners,
Uncle Ray.
yeah. So you say x minus 5 equals e to the power of 2. X is equal to e squared plus 5. E squared plus 5. 12.31. Oh, it's Dominique with the silver, Charlie Kirk, and the gold Forest. All right. So you guys remember that? Ooh, yeah, I'm gonna change back up back here. Uh, okay, so okay, you guys know the Android quiz is on Monday. The questions look a lot like the Kahoot we just did. Right? Um, your Alex 8586, I did bump that due date to Monday, and any papers that you guys have turned in so far, they've all been returned to your folders. So you guys have access to all of them.